Okay, this is the second part of the recap ECO242 series. Okay, second and the last video. So now I want to do 6 questions on hypothesis testing that involves the t-distribution, just in case you totally forgot how to do these types of questions. And then as I mentioned in the last video, please do all the revision questions on the study guide. Okay, and then for the 6 questions that I'm going to do, I will focus on the comparison between the computer t-statistic and the critical t-statistics. Okay, so in other words, strictly speaking, you still have to answer the interpretation part. Remember the 5th step of hypothesis testing, but I'm not going to focus on the 5th step in the next 6 questions. As I said, I will focus on comparing between computer t-stat and critical t-stat with the aid of the graphical sketch. Okay, so the first 2 questions relates to two-sided test, and then just in case you don't remember the decision rule, this is the reminder. We reject the null hypothesis if computer t-stat is greater than both critical t-stats, or if the computer t-stat is smaller than both critical t-stats. So look at the keyword both. Remember when after you found the critical t-stat from the t-table, you have to add plus and minus so that there are 2 critical t-stats in total for the two-sided hypothesis testing. And then when you look for the critical t-statistic, remember in the top row of the t-table, it gives you half of the alpha. Remember, this is a two-sided test, so we split the alpha into 2 equal parts, half of the alpha on each side. Second row of the t-table would give you the full alpha. So let's look at the first example. Okay, sample size is 20. K is 2 for these 6 questions. I assume all 6 are bivariate regressions. So K must be equal to 2, 1 constant and 1 slope parameter. So degrees of freedom would be n minus K, so it makes sense for it to be 18. Alpha is 5%, and then I ask you the question, null hypothesis, do you think in the PRF the slope parameter is 0? Alternative hypothesis, do you think in the PRF, the slope parameter is not equal to 0? So from a statistical point of view, I want to know which hypothesis is more likely to happen. And then computer t-stat, I just want to simplify method. You are supposed to be the one to calculate the computer t-stat, but let me give you the computer t-stat, 2.345. Now critical t-stats, how can I find plus or minus 2.101? Okay, so keep in mind, degrees of freedom 18, alpha 5%, two-sided. So let's look at the t-table. So if you open your statistical formula distribution table, degrees of freedom is 18. Okay. Remember, two-sided hypothesis testing alpha is 5%. So top row of the t-table gives you half of the alpha, 2.5%. Second row gives you your full alpha, 5%. Then we look for the intersection. This is why the critical t-stat 2.101, but remember, since it is a two-sided test, we add plus or minus so that we have plus or minus 2.101. Okay, and then if we look at the graphical sketch, okay, the 2 rejection regions, okay, half of the alpha, critical t-stat plus or minus 2.101, but computer t-stat 2.345. Okay, so since the computer t-stat is greater than both critical t-stats, so we reject the null hypothesis for this one. Okay, I hope you are happy with the first one. Okay. Second question. Another question on two-sided hypothesis testing. I changed the sample size to 22, K is 2, so degrees of freedom is 20. Alpha, I changed it to 10%, so two-sided test, null hypothesis. Do you think the true slope parameter is equal to 1? Alternative hypothesis. Do you think the true slope parameter is not equal to 1? And then I give you computer t-stat. Again, you are supposed to be the one calculating that. Computer t-stat 1.234. Now, how would I be able to find the critical t-stats? So degrees of freedom is 20, alpha is 10%. Let me undo all these things. Okay, degrees of freedom is 20. Alpha is 10%, so the top row gives you half of the alpha, 5%. Second row gives you your full alpha, 10%. Then you look for the intersection. And this is how you find the critical t-stat 1.725. Then all you have to do is to add plus or minus. Okay, so let's look at the graphical sketch. The critical t-stats plus or minus 1.725, but your computer t-stat 1.234, it does not lie in the rejection region. Okay, then you have to say, since the computer t-stat lies between the two critical t-stats, we do not reject the null hypothesis. So if we do not reject the null hypothesis, then it means from a statistical point of view, the null hypothesis is more likely to happen. So it means most likely in the PRF, the true slope parameter is equal to 1. So we have done 2 questions on two-sided hypothesis testing. So let's move on to do 2 questions on one-sided right tail test. Okay. So just a reminder, for one-sided right tail test, we reject the null hypothesis if computer t-stat is greater than critical t-stat, and there is only one critical t-stat. And then when you look for the critical t-stat, the top row of the t-table gives you your whole alpha. Because of one-sided test, we do not split the alpha into 2 parts. In fact, we have the whole alpha on the right-hand side of the graphical sketch. Okay, so to fully refresh your memory, let's do questions 3 and 4. Third question, sample size is 20, K is 2, so degrees of freedom is 18, alpha is 5%, so this is my one-sided right tail test. Null hypothesis, do you think the true slope parameter is 0? Alternative hypothesis, do you think the true slope parameter in the PRF is actually greater than 0? It means positive. Computer t-stat, I give it to you out of friendliness, 1.858, so now we have to look for the critical t-stats. Degrees of freedom is 18, alpha is 5%. Degrees of freedom, 18. Alpha, 5%. Remember, for one-sided test, we only need the top row. The top row gives you the full alpha, 5%. So this is why the critical t-stat is 1.734. Okay? And then from the graphical sketch, you can clearly see, okay, your whole rejection region gives you the whole alpha. We have the whole alpha on the right-hand side because of the words one-sided right tail test. So critical t-stat 1.734, but computer t-stat clearly lies in the rejection region. Therefore, since the computer t-stat is greater than the critical t-stat, we reject the null hypothesis. So in other words, it means from a statistical point of view, the alternative hypothesis is more likely to happen. Meaning in the PRF, the slope parameter would most likely be greater than 0 or positive. Okay, let's look at the fourth question. Sample size, I change it to 27. K is 2, so degrees of freedom is 25. Alpha, I change it to 1%. Then I ask the one-sided right tail test question. Null hypothesis, do you think the true slope parameter is 2? Alternative hypothesis, do you think the true slope parameter is greater than 2? Computer t-stat, again, I give it to you out of friendliness, 2.123, and then the critical t-stat. So degrees of freedom is 25. Alpha is 1%. Degrees of freedom is 25. Alpha 1%. One-sided right tail test. So the top row of the t-table gives me my full alpha. So critical t-stat is 2.485. Okay. And this time you clearly see the computer t-stat does not lie in the rejection region. In other words, since the computer t-stat is smaller than the critical t-stat, we do not reject the null hypothesis. Then it means from a statistical point of view, the null hypothesis is more likely to happen. Meaning in the PRF, the true slope parameter would most likely be equal to 2. Okay, so we have done 2 questions on one-sided right tail test. Then we conclude this video by doing 2 questions on one-sided left tail test. Okay, just a reminder for one-sided left tail test, everything is the opposite mirror image of one-sided right tail test. So for one-sided left tail test, we reject the null hypothesis if computed t-stat is smaller than the critical t-stats. And again, since it is a one-sided test, we have the whole alpha on left-hand side this time, graphically in the graphical sketch. And then for the top row of the t-table, when you look for the critical t-stat, the top row of the t-table gives you your full alpha. So let's do question 5. Sample size is 20, k equals 2, degrees of freedom is 18, alpha is 5%. So this is the question. Null hypothesis, do you think the true slope parameter is 0? Alternative hypothesis, do you think the true slope parameter is smaller than 0, which means negative? Computer t-stat, I give it to you, minus 1.999. Critical t-stat, the trick is that after you found the critical t-stat from the t-table, you must add the negative sign to change it to negative. So 18 and 5%. 18 degrees of freedom. Alpha is 5% one-sided. So 1.734, but we have to add the negative sign. So the critical t-stat is minus 1.734. Okay? And then this is the graphical sketch. Since the compute, you see the whole rejection region or your alpha is located on the left-hand side of the graphical sketch because of the word one-sided left tail test. And since the computed t-stat minus 1.999 is smaller than the critical t-stat minus 1.734, then it means we reject the null hypothesis. Then it means from a statistical point of view, the alternative hypothesis is more likely to happen. Meaning in the PRF, your true slope parameter would most likely be negative or smaller than 0. So for example, it could be a negative relationship between interest rate and investment. So you have a negative slope parameter, or alternatively, negative relationship between work hours and maybe your students, part-time work hours and the marks, because the longer time you spend as a student working part-time, it could have a negative impact on your academic performance. And then the last question, before we finish the revision of the first 6 or 7 chapters, would be example 6. Sample size is 32, k is 2, degrees of freedom is 30, alpha is 1%. So again, one-sided left tail test, null hypothesis, B2 is 3. Alternative hypothesis, B2 is smaller than 3. Computer t-stat, I give it to you, minus 1.258. Now we have to look for the critical t-stats, 30 and 1%. We have to go all the way down, 30, 1%. Then we have to look for the intersection, so 2.457. But remember, we must add the negative sign. Should change it to minus 2.457. Okay, minus 2.457, and look at the graphical sketch. Since the computer t-stat is actually greater than the critical t-stat, this time we do not reject the null hypothesis. Then it means from a statistical point of view, the null hypothesis indeed would be more likely to happen. Meaning in the PRF, the true slope parameter would be equal to 3. Okay, so I hope after doing these 6 questions, you have got all the memories back with regard to the 3 types of hypothesis testing. On the constant or slope parameter, we focus on the slope parameter actually from now on, especially for this module, ECO311. And then again, as I mentioned right at the beginning, you mustn't neglect the interpretation part, step 5 actually. Remember, it is a 5-step procedure, okay? So in the next week's lecture, we will move on to chapter 7. And from chapter 7 onwards, we would officially move on to multivariate regression analysis. Thank you.